Okay, welcome to our third problem for our quiz yesterday under the topic analysis of tension members. So this is from the other block. So the first problem that they have is almost the same as the first video. So this will be the another problem that they have given, or given to them. Okay, so let's solve. So for this case, we have a welded member. Okay, so we have an L 6 by 6 by 3 eighths angle welded to a 3/8 inch gusset plate as shown. All steel is Fy is equals to 36 ksi and Fu is equals to 68 ksi. Calculate the governing allowable tensile strength capacity. Okay, so let us solve this one pertaining to GSY and NSR limit states only muna, no? Kasi we don't yet know or have discussed yung shear block. Okay, so again, our section is an L6 by 6 by 3 eighths. Okay, and then we have a 3 inch thick, no? So both thickness of the plate and the L shape are the same, so will not a problem. Pero if ever one will be a different thickness, you have to check both, or whichever would be more critical, ano? Okay, and then we have Fy is equals to 36 ksi, then Fu is 68 ksi. Okay, allowable tensile strength. So allowable means ASD ang ating design philosophy. Okay, so we have first yung GSY natin or gross suction yielding. So Pn over omega, that is Fy Ag all over 1.67. So we need the value of the area for our section. So here, let's look for 6 by 6, 6 by 6 by 3/4. So by 3/4. This one, and then this one. Okay. For area, we need the value of 8.46. A for area. So we have here 8.46. Okay, so we have Fy, that is 36, keep per inches squared multiplied by 8.46 inches squared lower 1.67. So Pn over omega for GSY is 36 times 8.46 lower 1.67. That is 182.371 kips. Okay, that is for GSY or gross section yielding. Next, we have net section rupture. Okay, for net section rupture, Pn over omega, that is Fu Ae all over 2.0 rather. Okay, so we don't have Ae yet, which is equals to U times An, and An is equals to Ag minus Nb DET. However, since our connection is a welded connection, so you don't need to punch bolts to make holes for the bolts. So ang AN natin is equals sa AG. So we don't need this one. Okay? So what's next is for our shear lag factor. Okay? For shear lag factor, so since our leg is just connected into one leg, no? So looking at our table, okay? And so for all section, potential load is transmitted to some but not all, or longitudinal wells or bilongitudinal wells in combination with transverse wells. So yun tayo. So pasok tayo sa case 2. And of course, transmitted tayo by what other cases? So see, case number three is for transmitted only by transverse weld, and then case four is transmitted only by longitudinal welds. But as you can see on our solution, that our problem is do have ano no looking at our problem, it has a longitudinal, so this is our direction of loading. So ito yung longitudinal niya, ito yung kanyang transverse, so combination siya ng dalawa. Okay, so it means na for this case we will just use case 2, okay, kasi we do not satisfy either case 3 or 4. So case 3 again is only for transmitted via transverse weld or kapag perpendicular lang siya, and then for longitudinal one. So case 2 lang po tayo for this problem. Okay? So case 2, so U2 is equals to 1 minus bar x con over L con. Okay? So what is our connected side, connected end for this case? So looking at our shape, since angle natin is equal, so both the shorter and the leg are the same value yung centroid, distance na from the centroid. So we have here 1.77, and of course that is the same sa bar x natin, which is also 1.77. Okay, so 1 minus 1.77 inch over L con. L con natin is yung connected length natin, and for this case ang kina-calculate lang natin for L-con is the transverse lang. Okay, transverse. I mean longitudinal only. Okay, so longitudinal length, so that is 6 inches. Okay, so U2 equals to 1 minus 1.77 divided 6. That is 0.705. Okay, let's double check. 3/4. Ano bang given natin? Baka mali yung nakita ko, no? 3/8. Oh, I'm sorry. So it should be 3/8, not 3/4. So, okay. So mali yung area. And ano natin, ano? So we will just adjust the value. Okay. Okay. So this is, area niya is 4.38 only. So mas lighter pala yung section natin. So this is 4.38. So definitely our capacity will adjust also. So that is 4.38. So 36 times 4.38 divide 1.67, that is 94. Okay, 94.419 kips. Alright, then here our AG or AN natin is the same as AG, which is 4.38. It just paired, and then our connection, that this will change also. So for L shape, that is bar Y, and then 1.62. Okay. 1.62. 1 minus 1.62 over 6, that is 0.73. Okay, so Pn over omega now will be Fu, which is, so given natin 68 psi, so 68 kip per inches squared, times Ae, that is U natin is 0.73, times An, which is 4.38 inches squared. So cancelled out. Pn over omega is 68 times 0.73 times 4.38. that is 217.423 kip. Okay, that is the value for GSY and NSR. Okay, so now what we need is the governing load. Of course, the governing load will be the lesser of the two. So this will be our governing load. Okay, therefore, our answer, or our allowable, is equals to 94.419 kips. Okay, but again, we still have one other limit state to discuss. But for now, this is the governing load.